All right, everyone, welcome to this week's topic. We're going to be going into something a little different here that basically is a coverage of automotive fuels and combustion efficiency. And one thing that we should all be aware of in today's marketplace is that efficiency has been a major driving contributor to what we're seeing happening within the automotive market. And the types of fuels and the way that we're getting that efficiency from the engines that we choose to use varies by manufacturers, but everyone is really trying to obtain the same end goal, and that is to get the most power out of a single drop of gasoline that we possibly can, and therefore give us the best efficiency or usage of that energy that we're burning. And there's a lot of complex factors involved in that. But this week, we're going to focus on the types of properties of gasoline and diesel fuels. We're going to also look at what octane and octane ratings actually mean, why they're important. We're going to look at normal and abnormal combustion of gasoline and diesel engines, sometimes known as detonation. We'll also understand or be able to explain what the cetane and the cetane ratings actually mean, and then summarize what all of the properties of these different fuels, what it is we're actually looking for. What properties of these different fuels make them advantageous or perhaps not so advantageous, depending on what the system is. So fuel, what is this stuff, right? Automotive fuel is any substance that can be burned to produce heat energy, and almost any substance will burn and give off some kind of energy. It could be a liquid, a gas, a solid. You can think of different examples of this as liquid gasoline, and then some of the explosive materials that we're even aware of, not that we run many cars off of dynamite. Most passenger cars burn liquid gasoline. This is the most common method. And then we have quite a market, even though it mentions a few, that consume diesel fuel. We have a large trucking industry that operates on diesel. We have something called Gasohol, and we have alcohol and other alternative fuels, such as you might have heard of propane, for example, that some vehicles are powered with. There are three main areas that we want to focus on, and the first one would be combustion, and that's that reaction that occurs when the fuel is burned with an oxidant, or oxygen in our case, and this usually happens in that combustion chamber. Now there's normal combustion, right, which is primarily a factor controlling good fuel economy. The best normal combustion usually means we're getting the most maximum power out of whatever we've used as a fuel source. And at the same time, we want to have low exhaust emissions that can also serve a long engine life. We don't want to use, like I mentioned before, dynamite as a joke, but honestly, while it gives off a lot of power, it would be hard to control and would be damaging. There is abnormal combustion, and that occurs when combustion happens either too quickly or too slowly. And you might have heard this before about cars that make these funny noises, sometimes referred to as pinging in some cases. The next part that we need to talk about is combustion efficiency, and that's a measurement of how well combustion consumes the fuel's heat energy. For maximum cylinder pressure, right, we get that propulsion down the road, but we want the minimum exhaust byproducts, which cause pollution, which obviously in California is a big deal. Understanding the factors that affect this proper fuel combustion to isolate many of our vehicle problems is a fact that most technicians need to deal with. Being able to understand what the different exhaust gases tells us a lot about what's going on in that combustion chamber, whatever's coming out the back, right? Sort of like that garbage in, garbage out. If we got bad combustion, we're going to have bad pollution. So let's talk about our most common type of automotive fuel, gasoline. Gasoline is highly flammable. I'm sure that most of us have had some experience around gasoline. And on top of its flammable characteristics, we have to try to control that. And we do that by using what they call anti-knock additives. And these are designed to slow down the burning of gasoline and help prevent engine ping or knock. And this is where that octane rating comes in, because this tells us a lot about how, I guess, volatile the gasoline is. If it can be controlled to a certain temperature. Obviously, the more additives that we put in, there's an additional cost associated with it. And this brings us to the gasoline octane ratings that we need to understand. So there's an octane rating, and that's the measurement of the fuel's ability to resist knock or ping. And the octane is one of several flammable hydrocarbons that forms during the refining process. High octane gasolines resist knock and they resist ping better than gasoline with low numbers. So it's required by high compression or turbocharged supercharged engines, because as we increase pressure, especially in those turbocharged and supercharged, we're going to increase the temperatures, and those temperatures can cause gasoline to go off at different levels. So the higher the octane, the more certain we are at what temperature it will burn, versus a low octane that may go off at a lower temperature or a higher temperature and can cause problems within the engine itself. So those low octane gasoline numbers that we see here, those are suitable for normal compression, high efficiency engines. Automakers will recommend the specific fuel octane ratings for each vehicle. And really what that's doing is it's trying to help us control where that flame will go off. In other words, we use a spark plug, but if we've got too much pressure and the heat elevates higher than that, that gasoline can go off before we get to top dead center, which is going to adversely affect our ignition timing. We may be trying to hit a certain point where we want the gasoline to be ignited, but it may unintentionally be going off sooner than what we wanted, or it may not even be burning as hard as it should. This is where that octane rating plays such a critical factor in what the vehicle was designed to operate on. Another important part of the gasoline combustion process is how gasoline must mix with the right amount of air to burn properly. You'll often hear this as a stoichiometric ratio. And this is basically 14.7 parts to 1. But what does that mean? That's 14.7 by weight to 1. So in other words, 14.7 pounds of air to 1 pound of gasoline. This is a volatile air-fuel mixture that must be compressed, pressurized, and then ignited. This creates the perfect storm for this fuel mixture to go off, resulting in combustion or a rapid oxidation that produces heat and the expansion of gases and ultimately engine cylinder pressure, which is what gives us that propulsion down the road. Normal gasoline combustion happens when the spark plug ignites the fuel and creates the burning process. We got this pressurized air fuel mixture, and we light it off with this quick flick, very similar to a Bic lighter, but under a lot more pressure. It takes only 3/1000ths of a second to start this ball flame to start rolling, and that gradually expands as it burns more of that fuel air mixture as it comes up to TDC, which is going to be timed at the perfect point to push down on that piston. You'll find that some cars actually will fire this spark plug up to 3 to 4 times in one cycle just to constantly be lighting off that flame, especially noticeable with direct injected gasoline engines that you'll learn about later. Those fuel injectors are able to keep adding fuel during the whole power stroke, which is why that makes them so incredibly strong for pushing vehicles down the road. This air fuel mixture is that stoichiometric fuel mixture I was discussing. This is chemically correct. This is that air fuel mixture that we're looking for. And for gasoline, that's 14.7 to 1. 14.7 parts air to 1 part fuel by weight. Always remember that it's by weight. A lean air fuel mixture is a large amount of air compared to the amount of fuel. So if we had 15 to 1, that's more air than what's desirable. If we had 16 to 1, that's even more air than what we want to fuel. A rich air fuel mixture is a large amount of fuel compared to the air. And in those numbers, maybe we see 14.7 to 1.8 or 14.7 to 2. There we've got too much fuel for the air mixture, and that's not going to give us the best potential power or efficiency out of that cylinder. Let's talk about abnormal combustion for a second. There's a lot of things that can lead to this, but this abnormal combustion happens when flame does not spread evenly and smoothly through the combustion chamber. This is particularly problematic with those low octane gasolines that can have variations in the fuel quality. This problem is made more common when we're dealing with lean air fuel mixtures, especially with direct injected. This is a very difficult thing to control, which is why we use such a high pressure fuel system in direct injected vehicles. There's high operating temperatures that'll also lead to this. When we have too much temperature in there, we can have pre-detonation. In these low octane fuels, I already mentioned a couple of times, but I can't stress enough how they are usually a culprit to some of this pinging and detonation for most vehicles that just aren't designed to run on it. You'll see detonation happen when a part of an unburned air fuel mixture, the N gas, explodes violently. This could happen at any point, and the engine knock is a symptom of detonation. That knocking is because in one part of the piston it has ignited harder than it should have and caused the piston to rock within that cylinder hole. That combustion chamber pressure rises so quickly that engine parts vibrate because of that abnormal detonation going on. This detonation can get so bad that it can damage components within that combustion area. That's a greater increase of that pressure that happens, and the heat in it exceeds the design tolerances of that vehicle. It can crack cylinder heads, it can blow out cylinder gasket, it can burn pistons, it can even shatter the spark plug ends. So it's important that we pay attention to this detonation to prevent this kind of serious internal engine damage from happening. Preignition or surface ignition is another condition that we need to be aware of. This is usually caused by those overheated surfaces in the combustion chamber that ignites the air fuel mixture, especially if there's carbon buildup on the top of the piston head. This carbon acts much like a piece of charcoal in the grill and will stay there glowing as fuel is being injected into the cylinder. And while that stays hot on the top like a piece of flickering ash in the air, it's just enough to light off that fuel mixture. And this causes that whole ignition cycle, that combustion cycle, to start before it should in normal combustion, which can lead to this pinging and knock or light tapping noise heard during the pre-ignition system. This can also result in what we call high NOx values for pollution. So something to be aware of is that carbon buildup is going to increase pressure in that chamber and therefore create heat. We also have something called dieseling. Dieseling is when an engine, when you shut it off, it's called run on. It keeps running. It may run and shake and shut off harshly. Some cars won't shut off at all. What this does is the engine keeps running after the key is turned off, and that's because the gasoline engine ignites fuel from heat and pressure that's already generated. Imagine this, they call it dieseling, even though it could happen on a gasoline engine. That doesn't make sense because a gasoline engine doesn't run on diesel. Well, dieseling happens because the top of the cylinder head has gotten so hot that it injects a little bit of fuel and it lights it regardless if the ignition spark has been shut off or not. And that's how it gained that term dieseling, because it starts to sound very rough like a diesel engine. We also have another condition called spark knock, and that's when the spark timing that is too advanced causes combustion pressure to slam into an upward moving piston. So this piston's moving up, but the combustion process has already started and is starting to push back on that piston that's coming up. And it really wants to be on the downward swing. That causes pinging under load and is actually fighting the system as far as efficiency of moving the car down the road, because you've got cylinders that are pressing back against other cylinders because it's starting too soon. To find causes of ping, we first need to look at our ignition timing with a scan tool, and we have to see, is there some reason that this should be starting early? If we see that our timing's okay, we may want to look at something else, maybe that carbon buildup that's holding that contained heat and therefore resulting in that pre-ignition. While this is not as common as some of the others that we've talked about, it does indeed happen if the timing is incorrect. Diesel fuel is thicker than the crude oil, right? And so a gallon of diesel fuel contains more energy than a gallon of gasoline. There's a tremendous amount of energy in diesel fuel, but it doesn't vaporize as easily as gasoline, and the combustion requires fuel to be in a vapor state. So in order to do this, we usually have to use high pressure injection system that sprays the fuel into the combustion chamber to force this thicker fluid under high pressure to atomize in the air so it'll actually burn better. Actually, if it was too thick, it would not light. And you can imagine this. It's the same thing with gasoline to an extent. You could have a fire in a puddle of gasoline, but it's actually the vapors that are super dangerous that light for us. Now, when we talk about diesels, diesels have some similarities to gasoline in that they do come in different grades. Grades ensure that diesel fuel has uniform standards. Three diesel fuel grades. There's number 1, number 2, and number 4. Diesel engine makers select the grade that meets the needs of their engines. It's very important that we pay attention to vehicles that are diesels and we use the proper diesel fuel for that vehicle to keep it in best operating condition. Something to be aware of with diesel fuel is what they call a cloud point. And this is a paraffin wax. That's a substance that is in diesel fuel. And at very cold temperatures, the wax can actually separate from the other parts, and the fuel will turn this cloudy or milky color. That cloud point is the point at the temperature at which the paraffin separates from the diesel fuel. And this is an important factor, especially if you live in a cold climate. Another factor to be aware of with diesel fuel, although it does happen with gasoline as well, is water contamination. The water contamination is common with diesel engines, and the water mixed with the diesel fuel can clog the filters and actually causes corrosion of components. These vehicles will typically have a water separator that prevents water damage, used on many late diesel systems. One thing to be aware of with this is that fluids like water do not compress. And if you get too much water into a cylinder, you can do something that's called hydrolocking an engine. This can be very dangerous because if fluids don't compress, something's going to give, and this usually will lead to total motor failure of some sort. There are substances that we can add to both gasoline and diesel vehicles to try to help with this water contamination issue. But just be aware that this is fairly common with diesels, and we have tests for it as well. There's also what they call a cetane rating that indicates the cold starting ability of diesel fuel. Now, diesel fuel, because it's not as thin, it's thicker than gasoline, when it cools down, it acts very similar to oils, that oils themselves get thick under cold weather. So this higher the cetane rating number, right, the easier the engine will start and run in the cold weather. This can be extremely important with diesels. It's also very important when we're dealing with diesels that we're looking at the oils that we're putting in them, because normal oils will act up in cold weathers and create a very tough condition for diesels to turn over. A rating of about 45 is recommended by most automakers. So diesel combustion is quite a bit different than that of a gasoline. Compression ignition is what we call the engine that compresses this air until it gets hot enough to ignite fuel. The diesel fuel is thick and difficult to ignite, so we want to put those under high pressure to cause this atomization. The fuel is forced into the combustion chamber through this direct injection process, and this extremely high compression ratio heats the air in the cylinder. The fuel is sprayed into the hot air and begins to burn immediately as it sprays into that diesel engine. This is sometimes a difficult concept to understand, but when that amount of air is put under that kind of pressure and friction and it's compressed and you're adding that fuel, that's going to cause heat. Anytime we have pressure, we end up having heat, and that is going to cause items to combust to some extent. Now, when we go to look at the process of this, the normal diesel engine, you can see the piston moves up and it's compressing the heat in the air in that cylinder. And in this case, right, we have a little ball at the top. And that is where the diesel fuel will slowly be squeezed out in that combustion chamber. And passing through that orifice creates this heat. That fuel, as it comes down into the combustion chamber, will start to ignite and therefore will start to build up pressure as it expands and burns. One of the newest items that we've seen in the development of diesels has to do with what they call a selective catalytic reduction system, or better known as an SCR cat. That automatically sprays diesel exhaust fluid, often referred to as DEF fluid, into the exhaust system. This is a mixture of urea and deionized water. And the catalytic converter breaks down toxic NOx emissions by using this deionized water and urethra solution. The rate of the DEF consumption is termed as what they call a dosing rate. That's how much actual urea and deionized water is being entered into this SCR catalyst. And it's often referred to as burn off. Most diesel vehicles have dosing rates of 2% per gallon of fuel burned. So something to just be aware of. Typical maintenance will require that we fill this. The EPA requires vehicle manufacturers to install safeguards to monitor this system. When DEF fluid is low, a warning indicator illuminates, and it can actually limit the amount of starts that you have and tell you you've only got 20 starts until the vehicle won't start anymore. So they take this pretty serious. If the driver operates the engine without the DEF, the ECU can take action. It can cause this, significant reduction in engine power and even limit the driving speeds. And not only that, there's cars that simply just will not start until that has been filled and set. And that's to prevent people from skirting the law, let's say, and not adding this fluid to reduce those NOx emissions. So gasoline and diesel we've kind of gone over, but what about some of these alternative fuels? We have a lot of different fuels that have been tried. We've got, liquid petroleum gasoline, we've got biofuels, we got hydrogen vehicles, there's fuel cell vehicles. Propane was very popular. Obviously, we all know electrical vehicles are growing. There's natural gas and what they call P-series fuels. All of these have some application that have been experimented with to try to find the best model for the longest efficient use of fuels. We've seen a lot of things where corn alcohols for a while were very popular. And then sometimes, it doesn't turn out that they were, developed as far as they could, or were developed as far as they could, and they just couldn't get the efficiency out of them that was desired. We're still seeing a lot of growth in the hydrogen industry along with the electric right now. The liquid petroleum gas was very popular for a period of time. This was used in a lot of our buses and so forth for public transportation. It was used on both automobiles and trucks, and it was one of the lightest fractions of crude oil that's out there. It's very similar to gasoline, but this is a vapor at temperature, at room temperature, and usually at pressure. So this usually requires a special fuel system. Any of you that have run down to get your barbecue grills filled understand that they have to inject this propane into a tank under high pressures. That is a gas, and often it's accompanied with a foul odor that lets us know if there's a leak. So biofuel vehicles look very similar to traditional cars. You'll see here that they pretty much have an engine in there, they have an ECM, they have the 12-volt system and transmission. What may be different on a lot of these is you'll have some kind of float assembly in the tank. And that float assembly usually is very special. It's not only measuring the level of the fuel, but it's also determining what percentage is there. So a lot of these cars you may find that run on pure biofuel, or they may run on a combination of gasoline and some type of biofuel. And that's going to affect how that fuel burns in the engine. This sensor that's back there is able to determine that. And then from there, it's able to tell the engine, hey, this is how you need to adjust the timing rate. If it's a propane system, you may see something in there that's got a pressurized tank. And all of these systems pretty much work under similar conditions depending on what the fuel is that's being used in the vehicle to try to expand its efficiency. Biofuels are considered renewable, and some biofuels recycle waste products. and the crops are planted each season. So for example, with corn, a lot of corn was planted so that we could extract this corn biofuel. There's also been a lot of play with certain types of lily pads and so forth on some lakes that they're able to get some of this energy as well from. Lots of different ideas out there. It's always interesting to watch what people are trying to use to harness some renewable energy source so that we don't create the carbon footprint that we do under many of our traditional methods. So one other type of fuel that's out there is alcohol, and I'm not talking about a beer that you have that you dump down there, but there's actual alcohol that is clean burning, but it's very expensive to use and produce, and engines require serious modification. There's two types of alcohol that are primarily used today. There's ethanol and there's menthol. In either one of these alcohols, you're going to find that they are extremely clean burning and usually high output style engines. Funny story about this, my first experience with ethanol actually had to deal, or ethyl alcohol, was with motorcycles. I remember when I was younger going to a track that this is all they burned was the ethyl alcohol. And they had very small gas tanks just for racing, but it was extremely powerful fuel to use for these engines that were designed to burn this type of fuel. You'll also see in many of these systems with ethanol that that's a renewable fuel that's made from corn and other plant-based materials, such as the lily pads I was mentioning. It's colorless, it's not toxic, but it is toxic, and it is highly flammable. Ethanol is blended with gasoline, and a common blend is E10, 10% ethanol, 90% gasoline. You may have even noticed this when you were at the gas pump, because sometimes this will be listed out there and they'll tell you about the ethanol blends. Now, ethanol fuel characteristics, they're higher than that of gasoline, but they create less energy and lower emissions. So there are some pros and cons to looking at ethanol as an alternative, which is why for a period of time there was many places that were using corn oils and so forth as energy sources, because it was considered renewable energy that we could use. One other item that's related to this ethanol is that there's sensors that monitor the fuel contents through measurement of combustion efficiency. And they look at the flow of fuel through a sensor that is sampled. The engine ECM then adjusts the fuel curve, and the fuel curve is the amount of fuel injected into the cylinder for the operating conditions. So keep in mind, we can control when the spark happens, when this combustion actually is controlled. We can also control the amount of fuel that's going in. And that's why you've seen so many ECMs or electronic components involved in the car. We just have much greater control over what we want to do with various substances and various outputs of the engine. Ethanol may also be called ethyl alcohol, so just be aware of that sometimes it goes by both names. So something to be aware of with flexible fuel vehicles, or FFVs, is that they operate on a mix of up to 85% ethanol and only 15% gasoline. Their fuel system can sense alcohol gasoline percentages, as I was mentioning earlier. The fuel system adjusts the fuel injection as needed to maintain the correct air to fuel ratio. Obviously, this can vary anywhere between 85% ethanol all the way down to 15% ethanol in the other portion gasoline, and the engine has to adjust for these changes. Methanol is made from wood chips, and it creates this petroleum garbage and manure it can be made from as well. It's colorless, it's extremely poisonous and flammable. It has a very strong odor. It may be called methyl alcohol. You may have heard of this because sometimes people that try to make their own alcohol at home, if they're not careful, can end up creating what they call wood alcohol. And this usually results in causing people blindness. Methanol is commonly used as racing fuel, and that's because this burns cooler than gasoline, and it does not produce a visible flame if there is a fire. For increased safety, racing organizations have often required additives in methanol racing fuel to make the flame more visible. Nothing like being stuck in a cloud of hot fire that you can't see, right? Very strange behavior with this, which is why they required it in racing. Gasohol is a mixture of gasoline and alcohol, usually grain alcohol. It's usually 87 octane gasoline, and a typical blend is 10% alcohol and 90% gasoline. Adding alcohol can increase the actual gasoline's octane, and it can reduce knocking. Fuel systems and engine modifications are not needed for this type of mixture in a vehicle. Now, natural gas is a clean burning gas that we have that's not a non refuelable fuel. And there are two forms that are used in vehicles there's compressed natural gas, CNG, and then liquefied natural gas, LNG. You'll see these in the heavy duty market, especially with some of our buses and public transit systems that are out there. That would be the most popular forms of them. Now, hydrogen's been one that you've probably heard a bit about. It's expensive to produce and store, and automotive use is limited to test vehicles. That's until recently. They've actually started to mass produce some of these hydrogen driven vehicles that are out there. There's no harmful emissions because the only byproduct is water vapor. You may have heard of the Toyota Mirai. This is a publicly offered and sold vehicle that runs on hydrogen. Their production method uses what they call electrolysis and ocean salt water that has been developed. They've also used this with combinations of batteries on these vehicles so that they can use this electrolysis to create electricity, which actually helps to re-energize or act as an alternator for recharging the batteries on electric vehicles. It's becoming widely popular and appears to be one of the main fuels to watch in future cars coming out. These vehicles that you'll see out there are often referred to as fuel cells, and they combine hydrogen and oxygen to produce electrical energy. They use this gas permeable membrane that's coated with a catalytic platinum foil. The membrane is sandwiched between two electrode plates, and the hydrogen gas flows through the anode plate membrane, and the compressed air flows the other way. This is very much how a lot of our hydrogen vehicles are working today, especially when we start looking at fuel cells. The catalyst in these vehicles causes hydrogen gas to separate into positive hydrogen ions, protons, and then electrons that you might be familiar with from our electrical classes. This causes a potential difference of electrical energy. And when current is drawn out of a fuel cell, oxygen molecules separate and combine with hydrogen ions. Water and heat are the two emissions that are created out of this. So it literally, out of the tailpipe, you've got drips of water coming out of it. Here's the typical arrangement of a hydrogen fuel cell vehicle. You'll notice the high voltage battery pack in the back and then a fuel tank that holds the actual hydrogen. There's a transmission and then there's a power electronics controller, and you'll notice that we still keep that 12-volt battery that runs a lot of our normal systems in the vehicle. We have that converter and the thermal system for cooling, and then what they call an electric traction motor or a motor generator. You'll also notice in there the fuel cell stack, and that's where the hydrogen is pumped through to create this electrical recharging of the high voltage battery. Another fairly popular fuel is propane, and that's liquefied petroleum gas. It has a low boiling point which allows it to vaporize into gas in colder climates, so it still is ideal in cold areas. It's a clean burning fuel and it's often used with fleet vehicles. I remember for a long time seeing a lot of our local buses and public transport using propane as their fuel source. And what can we say here? Electricity. I think this one's gotten a lot of attention in recent months. High efficiency electric motors and large storage batteries are used to power electric vehicles. And you'll see vehicles out there that are 3-phase, 6-phase, 9-phase vehicles that are out there to create this electrical propulsion. It's a viable means of propulsion for trips up to several hundred miles. Again, the range is limited on solely electric vehicles, which is why you're starting to see this hydrogen adaptation occurring, a way to expand that that distance. But for the most part, you know, a 300-mile range will get most people typically where they want to go. Imagine you pretty much could drive from here to LA and back on electrical charge. You need to plug these into a recharging station to charge the storage batteries, and you're probably all very familiar of the Tesla vehicles that have these DC fast chargers, they call them, to get those batteries up to optimum levels. Then lastly, we have P-series fuels, and these are blends of liquid fuels. They could be ethanol and LPG, hydrocarbon, a bunch of these different flavors that are added. They're clear, they're high-octane fuels that can be used in those flexible fuel vehicles. They cannot be used in gasoline or diesel-only vehicles. They have to be used in flexible fuel vehicles, and this usually has to do with the ability to control the timing and control those fuel injectors to give the right amount of fuel for the desired combustion that we want to get. All right, so that was a lot of information, a lot of different fuels out there, and I know a lot to absorb, but we got to get you at least aware of all the different types of fuel sources we're trying to use. Again, if you have any questions, please email me, send me some kind of response via email, and I will get back to you to clarify on some of these fuels. You may know of some other random fuel that's out there. There's a lot of different attempts being made for fuels that are less polluting. So again, feel free to reach out to me. I hope you enjoyed that. There's a lot of information there. I sure know every time I go through the fuel systems, there's something new that's on the market. All right, thank you guys.